Now, the enzyme secreted by the tongue is a lipase called lingual lipase. There's the function of the lipase right there. But lipase doesn't act very long, because as soon as you swallow, it goes to the stomach and the lipase is inactive. It's an enzyme that cannot stand the acidic environment of the stomach itself. But that's the function of the lingual lipase, all right? Now the major salivary glands, well hell, salivary glands are three of them: the parotid, the sublingual, and the submandibular. The parotid, P-A-R-O-T-I-D, sublingual, under the tongue, submandibular, under the plane of the mandible, right? Those are your salivary glands, and there are six of them. Three of them are paired, okay? Now, the dentition pattern, right? It's kind of interesting about the number of teeth that we have right here. Let me read some of this right here, all right? The reason I want you to know this is, I'll talk to you now. The reason I want you to know this is, most of you, I didn't, don't have room in our mouth for all of our teeth. We simply don't. So what are the teeth that we have? And this is the easiest way for me to show this to you here. I want you to write down four numbers: 21, 23, 2, 1, 2, 3. 2, 1, 2, 3. All right. Now, a jaw was an arcade. You have the upper arcade and the lower arcade, the upper jaw and the lower jaw, okay? Now, if we look at, say, the lower jaw, if we look at half of one of these arcades, one of these jaws that we have right here, we have a configuration of 2, 1, 2, 3 teeth in it right here. 2 incisors, I-N-C-I-S-S-O-R-S. 1 canine, C-A-N-I-N-E, or canine, I don't really care how that you do it. 2 premolars, and 3 molars. If you multiply all this times 4, about all this times 4, you'll have 32 teeth. This makes 8 times 4 is 32. That's the easiest way for you to remember the total number of teeth in the adult mouth, okay? Or give me this presentation right here, 2, 1, 2, 3 times 4, all right? But again, well, the molars are called the wisdom teeth. That's kind of a joke, but anyway, supposedly the older you get, the wiser you get. Maybe the less dumb that you get. Maybe that's the best way I could look at it. Okay, now, how would excessive vomiting affect the esophagus? There's a lady in my church several years ago said that she had a report from her doctor that she could not understand. I said, well, I'll be glad to read it to you, read it for you. She read it. No, she brought it. I looked at it, and I saw the term Barrett's esophagus on it. I looked at her and I said, you're eating late and going to bed, aren't you? She said, yeah, well, what's the problem with that? I said, because the acidic environment of your stomach is dissolving the lining of your esophagus. Okay, and Barrett discovered this right here. There is a change in the type of cell. There's a metaplasia of the esophagus. This is what Barrett's esophagus is, B-A-R-R-E-T-T-S. Barrett's esophagus is, okay? Barrett's esophagus is a metaplasia changing in one type of cell to another. Both of these are functional cells now. Both of these are functional cells. From a cuboidal to a columnar type of cell change right there occurs by persistent vomiting, persistent acid reflux, not vomiting. Well, vomiting could do something worse right there, but persistent acid reflux, because you eat late and you go to bed. If you're going to eat late, don't eat that much, and you might be all right. Don't make it a habit. Please don't make it a habit, okay? Because you do not need Barrett's esophagus. So if you keep on persisting this right here, metaplasia turns to dysplasia, turns to anaplasia, and this would cause esophageal cancer. It really, really can, okay? If the insult persists. If you could, now we're talking about several years of doing this right here. If you eat late and go to bed, eat late and go to bed, eat late and go to bed for several years, you're going to get cancer of the esophagus, all right? She had her warning. She quit eating late and going to bed. If you have to eat late, sleep in a blooming chair. Sleep sitting up. Anything's better than going to bed and getting acid reflux and damaging the lining of your esophagus, okay? Now, the overall function of the stomach. I've thought about this and thought about it, well, for a few seconds anyway. The overall function of the stomach is for protein digestion. Now, 30% of our diet is recommended to be protein right there. And it probably takes the complex carbs that we eat, not the simple carbs because they're already linear, the complex branch carbs, and it probably breaks them down to more linear structures. But the carb digestion is not our focus right here because it's not going to do a thing in the world to digest it. It's just going to make it more linear for the amylase from the pancreas to attack it. But it's going to break down the three-dimensional structures of the proteins. And that takes about 4 hours, 5 hours, maybe even 6 hours. It's kind of interesting. You can go to a Chinese place and eat a lot of starches, and about 4 hours later you're hungry again. But that's because starches stay in the stomach about 4 hours, 4 to 4.5 hours. Proteins stay there around 5 to 6 hours. So the more proteins that you eat, the longer you're going to be satiated or have this feeling of being filled up. It's just the way that it works, okay? So what I'm looking at right here is the overall function of the stomach right here is to break down the tertiary structures of the protein. That's the major function of the stomach itself, okay? It won't do anything to lipids. It's going to stop the action of the lipase from the tongue. And that's fairly minor anyway, the amount of lipase from the tongue, okay? Okay, now, the 4 regions of the stomach. I think we're going to have a listing of here of the regions of the stomach. And I'll call your attention to that page right now. Swallowing, swallowing, swallowing. Oh yeah. Figure 2412. The stomach. Well, what the hell. The stomach has 4 different regions. List for me the 4 different regions. You're going to see cardiac, fundus, etc., okay? And body and pylorus, in case you can't find them. Those are the 4 regions of the stomach. Now, as I mentioned earlier, as far as what peristalsis was, coordination of the longitudinal smooth muscles, longitudinal and circular smooth muscles to move the ingestion throughout the digestive tract right there. It's kind of different in the stomach itself because food's going to sit there for a while. There is an oblique of 45 arrangements. So there's 3 orientations to the stomach muscles themselves. There's a longitudinal, there's a circular, and there is an oblique. So there's a lot of churning that goes on in the stomach, okay? A lot of motion that goes on in the stomach, okay? So now the secretory cells in the stomach, their functions and their secretions itself. But before I do that right there, I may talk to you about HCl, and then I'll talk to you about the function of HCl. And then I'll hold off on this right here. The inner lining of a tubular structure is the mucosal membrane. There are modifications to the mucosal membrane, okay? There is rugae, there is plica, there is villi. Look up the functions of the rugae, the plica, and the villi, and give me a location of them. And they're going to allow for expansion. They're going to allow for expansion, okay? Tell me where that they are. Right? The rugae, the plica especially. Now the villi are going to allow for a little more, for a little bit distension, but they may lead to increase the surface area. They're mainly found in the small intestine, okay? But the rugae and the plica are found in either the esophagus or the stomach. Separate their functions, separate their locations, and give me a function for them, all right? Thank you. Now let's talk about hydrochloric acid just for a few seconds, and that'll probably finish us up on this one right here, okay, for today. But I got to stretch this thing out for a few days anyway. I do. Okay, you won't know the difference. Let's take a look at HCl. Okay. Now, hydrochloric acid is not secreted as such. We do not secrete HCl. We cannot store HCl in the stomach. So how is this stomach so blooming acidic? Well, in the mucosal membrane of the cell, the mucosal membrane, the cells of the mucosal membrane of the stomach, and here's a mucosal membrane of the cell itself. The lumen would be over here. Serosal membrane would be over here, right here. This is the mucosal cell that we have right here. Well, it's interesting that for hydrochloric acid to form, you know, it breaks down to a proton and a chloride ion. If you can secrete a proton and secrete a chloride ion at different locations, you got hydrochloric acid. I think that's great. If you can secrete a proton and you can secrete a chloride anion, you will form hydrochloric acid. But hydrochloric acid is not formed, not secreted as such, because there's no storage vesicle inside of a cell that can handle it. Nothing can handle hydrochloric acid as such, but there is, let me show you how this occurs right here. There are enzymes that'll break down carbonic acid. Let me show you what carbonic acid is. We've seen this before. Carbonic acid is CO2 plus H2O, forms carbonic acid H2CO3. All right. Now, it's a weak acid. It dissociates into a proton and HCO3 minus. HCO3 minus. This is the bicarbine. This is the bicarbine. Now, there are enzymes, a carbonic anhydrase enzyme in the mucosal cells of the stomach that will break down carbonic acid. And the beauty of this is, I've got a proton that I can secrete. There are protons that will pump the proton from the breakdown of carbonic acid into the stomach lumen. Right? So here I have a proton that comes from here, being secreted into the stomach lumen. Now all I have to do is come up with a chloride anion. All I have to do is come up with a chloride anion. Well, I've taught you about ion exchange mechanisms. Protons let's see, we've talked about potassium, we've talked about sodium, we've talked about protons, okay? We've talked about maintaining an ionic equivalent inside of a cell. Well, this is no different right here. I can exchange the bicarb ion for a chloride ion. I can exchange the bicarb ion for a chloride ion. Now, chloride ion builds up outside the cell. So I have chloride ions out here that will come into the cell, be pumped into the cell.